Right, okay, we are going to start the today lesson here. Sorry for the delay due to some technical error. Right, okay. Last week we discussed about the types of network and the other things relating to computer network. Right, today our topic is network topologies. Network topologies. You can write down on your note. Network topologies. Here I'm going to share in a presentation. Right. Here the topic network topologies. Right. These topologies actually explain the physical arrangement of the network. How you can arrange your devices. When you are establish the computer network system, you need several types of devices. It may be PCs, laptop, smartphone, like that. There are many devices with you. Then there should be a way to arranging them physically. Also, it should determine how transfer data from one location to another location. That determination also one of the part under topologies. Right. Here, the first thing you want to know, topology is the physical arrangement of the computer network. Especially here we are consider only local area network. Right. If you are going to establish a local area network, in that case, you should want to determine how to arrange your computers. These arrangement types, there are many arrangement types. These are called topologies. Right. Here, look at the note. Here, explain it. The first para explain what is network topology. Here it says physical or logical arrangement of the computer network. Especially here, you want to consider local area network. It is not applied for other network types, PAN, MAN, or WAN, only for the local area networks. Right. Then here the physical arrangement means how that particular devices represent the physical layout of the connected devices. Physical layout of the connected devices. The logical topology focus on the pattern of data transfer. Pattern of data transfer. Here we are mainly concentrate on the physical arrangement or physical layout of the connected devices. Right. Now you can write down the notes here. I will give time to complete that. Okay, starting. Right. Okay. Then I think you finish writing this statement here. In this slide, they explain what is topology. Here, the main thing is you want to remember topologies we are using to topologies represent the physical arrangement of the network. Especially, you are consider only local area network. If you are supposed to establish a local area network system, then you want to consider about this topology, how your devices or nodes, another name we can give for the devices within the network is node. How you want to arrange these devices or nodes on your within your network, local area network. Here mainly you have two types of topologies, physical and logical. Physical topology represent the physical layout. Physically, how you are going to arrange your devices within the network. Physical layout of the network. Then logical topology explain the how data travels from one location to another or within the network. That's the difference between this physical and the logical topology. Right, I think you finish writing this one. Therefore, I'm going to next one. Next, explain the types of topologies you are going to use on your network. Here, basically, we have 5 different types of topologies. According to these topologies, we are going to arrange our computers within the network. Right here, given 5 different types of topologies: bus topology, star, ring topology, tree, and mesh topology. Right, we should want to get the differences between these 5 types of topologies. Right, then we'll see one by one what are the features, what is the physical arrangement of their, and the advantages and the disadvantages. We should want to get some detailed information regarding these 5 topologies. Right. First, write down the slide here. Then we'll start one by one. Right. Then first write down the things here. Right, finish writing. I think you finish writing the things here. Here explain the types of topologies available or types of topologies you can use within your local area network. Right, here name 5 types of topologies: bus, star, ring, tree, and mesh topology. Right, then we'll see one by one. First, write down the subtopic, bus topology. Bus topology. Right. Here the arrangement is they are using only one cable. Throughout this cable, we can connect each devices. There is a one cable from one end to another end. There is a starting end and the closing or stop end. This line they are using to connect each devices. Right. Here, look at the description of the bus topology. Here says another name for bus topology is line topology, because of they are using one single line. Therefore, it is also known as line topology. Right. Here it's a single cable. That's the technical name for this line is backbone. Another name. There are many names we can give for this bus topology. One name is line topology. Then another reference is backbone. Backbone represent the line. Use this. They are use this backbone to connect each devices to the network. Right. Mostly they are using coaxial cable to connect computers with each other. That's the law because of their cost. Coaxial cables you can find at low cost. Therefore, they are using coaxial cables. Mostly they are using coaxial cables to establish the bus topology. Right here, they are saying you must have a network card. That last week we learned what is network card. Network card we must need to connect computers with each other. Then they need coaxial cables. Coaxial cables for the medium. They are using to connect computers with another one. Coaxial cable is the medium. Then RJ45 is the port. Right. That all of these things we learned last weeks. RJ45, you need RJ45 ports to connect computers with each other. Right. Write down this paragraph on your books. Write down, first write down. Right, finish writing. You need more time or finish writing. If you are finished writing here, explain about bus topology, also known as line topology. They are using one single line that is called backbone. Throughout this backbone, they are connecting devices to the bus topology. Then it needs a network card. If you want to connect with each other, you must have a network card inside your computer. Then you can then they are explained about the cables that you can use on your bus topology. The one common type is coaxial cable. Then again, another type they are saying RJ45 network cable. Right? Can someone tell me what is RJ45 network cable? What is that? Another name for that. RJ45 is the port name. That particular port you need on your computer to connect the cables. Right here, not giving the exact name. They are saying RJ45 network cable. Can someone suggest another name for that? Normally, RJ45 port we are using to connect which type of cable? We learned. Yeah, sorry.
Twisted pair.
Twisted pair. Yes, it is correct. Very good. RJ45 network cable mean twisted pair lines. If you are using coaxial cable, the particular port you need on your computer is BNC port. If you have on your computers BNC port, in that case you are using coaxial cable. If your computer having RJ45 port, then you can use twisted pair cables to connect with each other. Right. Okay, that's the things you want to understand here. Right. Now look at the physical arrangement of your bus topology. Look at the diagram here. You can see carefully on the diagram here. In the middle, the bus topology, the starting point of the bus topology named as terminator. Then ending point of the topology. Here you can see the other side as grounded terminator. That's the ending point. This line between this terminator and the grounded terminator called as trunk cable, here name given as trunk cable. This is the backbone. Within bracket you can say when you are drawing the diagram, backbone. Right? Then backbone is the cable where finding the terminator and the ground terminator. Then you can connect your devices from both sides to the backbone. These devices here named as workstation. There are many names we can give to the devices within your topology. Workstation is another name. Nodes is another name. Normally you can say devices. There are three names for that: devices, nodes, or workstation. Right. The cable you find from workstation to the backbone is called drop cable. Drop cable. Here, remember these names. When you are drawing the diagram in your books, write down these names also. The cable you find from the workstation to backbone or trunk cable is called drop cable. Right. Then there are three workstations in this diagram: one file server and one printer. Like that, there are many types of devices you can attach with this topology. Right. The workstation, file server, printer, or any other devices together commonly called as node. Right. Is it clear, this picture? Then if you have any problem, you can discuss with me. If any not clear things, so to understand more, then you can discuss, you can ask problem. Right. Otherwise, you can draw this diagram on your books. Right. Draw it. Right, I think you finish drawing the diagram here. This is about bus topology. When you are asking what is bus topology, at least you will be able to draw this diagram. Therefore, remember the terms here. Workstation. The workstation are the devices you attach with your network. Here, the main cable known as trunk cable or backbone. The two ends of this backbone, the starting end is terminator. The ending or last end is grounded terminator. In between, you can attach your devices. These devices may be personal computers, workstation, file servers, printers. In that way, any kind of digital device you can attach with this network. Right. Okay, then I think you finished drawing it. Then we'll see some features of this bus topology. Right. Here the main features you have to remember. The single cable, especially you need to know, you have to remember the main cable they are using to connect devices from terminator to ending point. That is called backbone or single cable. Right. Then another cable you can find above diagram from workstation to backbone. That is called drop cable. Drop cable. Right. Another point you have to remember when you are drawing the diagram, you want to point out what is drop cable. Right. Then think about another point here, how data travels from one location to another location. Right. Then look at the diagram here again. If you want to traverse data, send in data from suppose this workstation, the workstation line above, right? That here my mouse pointer is around it. Suppose you want to send from this end, this station to the file server. Right. Then that particular, they are starting this workstation, starting sending data from this drop table, it put into the backbone. Right. Then that particular set of data starting to traverse throughout this backbone. Throughout this backbone, then it will go to the particular location where they need to go. And the data also travels throughout this backbone. Therefore, they traverse until to the grounded terminator. Once they reach to the grounded terminator, that data remove from the topology. Remove from the topology. In that way, the data travels from the, that's the pattern of traveling data from one station to another station. Right? Actually, this pattern defines the logical topology of the arrangement. Right. Okay, that's the point you want to remember when you are discussing about the bus topology. Right. Point out these points on your books, write down on your books. The first one, the bus topology is designed in such a way that all stations are connected through single cable known as backbone. This first feature describe about what is backbone. Then second feature describe about what is drop cable. Then third one describe how data travels through the bus topology. Then fourth one, they are saying how remove the data from the bus topology. Once the data come to the ending terminator, it automatically remove that particular sets of data from the topology. Right. Write down the points here. Right here, I think you finished writing the things here. Look at the point how data travels from one location to the other location through this bus topology. Here, once release the data from that particular node where you want to send in the data. Once release the data, that particular sets of data reach to all the other devices. That it will not be able to focus to the exact location where you need to send in the data. That's the another one disadvantage of this bus topology. Once release the data, that particular sets of data reach to all the other devices in the network. Right. That point here, on the third point, all stations available in the network will receive the message whether it has been addressed or not. That remember that point here under bus topology. Right here, I think you finished writing the features of bus topology. Right now, we'll move to discuss some advantages. Some advantages of the bus topology. Here, the first one says low cost cable. Here, they are using that earlier mentioned coaxial cables, or as well they can use twisted pair cables. Right. Also, they need small cost devices like hubs, switches. Therefore, they want no need to spend more money to establish bus topology. They are saying initial cost of installation is low. That's the one advantage when we are using bus topology. Then moderate data speed. That here, especially they are using coaxial cable or twisted pair cables. They can send in data in moderate speed. Speed actually up to, they support up to 10 megabytes per second. That's the one of the advantages we can consider by spending low money. Then familiar technology. That means if you want to arrange or establish bus topology within your local area network, you are using the familiar technology, well-known technologies, right? That's another advantage when we are using the bus topology, right? Then another advantage at last said limited failures. Right? Once you establish the system, the breakdown is happening very rarely under bus topology. That's the feature of bus topology. Right? The breakdowns are happening very rarely. Therefore, we can say limited failures. Right? That's the some advantages you want to know when regarding the bus topology. Right? Write down one by one of these advantages here. Right. I think you finish writing the things here. Here discuss here showing about the advantages of bus topology. The first one is low cost cable. They are using low cost cable, coaxial or twisted pair. Then installation cost also very low. Another feature here they are saying no need to using the hubs. Normally hub, that the particular device we are using to connect computers with each other. Normally through the hub they are connecting computers with each other. But in this case, bus topology, no need to use separate hubs. They are allowing to direct connections. Right? Here no need to assign or attach hubs to connect computers with each other. That's the one feature you want to remember under bus topology, under advantages. Right. Then they are saying about the speed of the data speed within this topology. They are saying it moderate. Moderate is also acceptable. They are using coaxial or twisted pair cables. That means moderate speed is available within this network system. It says up to 10 megabytes per second. Then they are using familiar technologies to all installation and maintenance and the other things. That is another advantage. Then another thing, the limited failures. Normally, the breakdowns are happening very rarely. Right? That's the some of the advantages under bus topology. Right. Then we'll see some disadvantages. Under disadvantages, they are saying extensive cabling. Right? The cable cost is low. That's the advantage. But the problem is your devices become more and more. That means you want to use more cabling. That's the meaning of extensive cabling. That's a disadvantage. You are using more cable mean that particular topology arrangement is become complex. Then difficult to troubleshoot it. Right? Once happen, that's earlier says the breakdowns happening very rarely. But however, suppose some kind of breakdown happen, then it is very difficult to find what's the place that error happening. That means difficult to troubleshooting. Right? Once the identify the troubleshooting, then again it needs to reconfiguration. This reconfiguration is difficult. That is why they are saying difficult to troubleshooting. Then signal interference. Signal interference means suppose if they need to send in data same time, two devices, two nodes send in the data simultaneously. Simultaneous means same time. In that case, the collide this happen. Right? No way to send in data at the same time by two devices. That's another disadvantage under bus topology. That again says at last reconfiguration is difficult time. Explain it under difficult to troubleshoot it. That means once the breakdown happened, once some error occurred in the topology, then you need to reconfigure reconfiguration that particular device. Reconfiguration. That means all the parameters you want to set again. Once you attach that one particular device to the computer network, then there are lots of configuration you want to do in your software side. Then you want to assign addresses, IP addresses, network addresses, domain addresses like that. Then people who are doing the network and such a things, they know the things need to do with the these computers. Once happen in the failures, so network errors, then you need to reconfigure those things again. The reconfiguration is much difficult under this bus topology environment. Right? That's the disadvantages we can identify under bus topology. Right? Write down this disadvantages also on your books. Right, write down it. Right, I think you finished writing these disadvantages. There are 4 disadvantages here we discussed. Extensive cabling. It needs more cables when more devices attached with your topology. Then difficult to troubleshooting when errors happen, when breakdowns happen. It's very difficult to identify the particular error occurred in which place, and reconfiguration also difficult, that I explained it. Then signal interference happen. In single interference mean the same time 2 devices try to send in data to another device. Right, we giving special name for that. Collide occurs when trying to send in data, when trying to send in 2 devices at the same time or simultaneously. Right, that's about disadvantages. Here, look at some diagrams also regarding the bus topology. This diagrams another view of the bus network topology. Here in the middle, the main cable, you can see there the terminator, starting and ending terminator. You can see in the red boxes there. Then station, workstation, 4 workstation attached with the system, one file server, and the printer. Here there's a hub also, but it is not necessarily to add in a hub. That earlier we mentioned under advantages. When you are using the bus topology system, no need to add in hubs, attaching hub with your network. But here they are saying one hub to the external things, right? It arrow marked here direct to external things, right? If you suppose want to add some to expand this network to another network, in that case it may be they are using a type of hubs, but it not necessarily for the bus network system, right? Do not need to write down, draw this diagram here, only look at and listening the things. Another diagram here, look at the diagram here also. They are saying how data travels from one location to the other location. This diagram says data sending start from the second terminator, second workstation here, sending frames to station 5. They are supposed to send in the data to station 5. Then they are release the data to the backbone. Then data travels through the backbone and identify the location 5 and send it receiving the data from location 5. But the problem is all the data, once releasing data from the location 2, all of this data travels to the other locations also. Right? That here not indicate that, but this data also going to other locations. That's the one problem. The other problem is, suppose the same time they need to send in data from location 3, then what happened? Think about what happened. The same time you need to send in data through the location 3. Then we say collide happen. That under disadvantages, I already explained it. It is not possible to send in data at the same time 2 or more devices. Right? That's the way of sending data under bus topology. The sending data, the pattern of sending data is known as what? Is known as what arrangement? Which arrangement? Logical topology. Logical topology. Right? This diagram explaining logical arrangement of the bus topology. Right? I think you received some idea about the bus topology. Actually, that's the things we should, according to our purposes, that's the thing we should want to know regarding the bus topology. Right. Then we'll move to the second type of topology called star topology. Write down on your books as a subtopic, star topology. Right. The star topology is the arrangement like a star. That name represent the physical layout, that we can get some idea about the how arrangement like. It's like a star, the physical layout. We should have a hub or switch. In this case, in the star topology, you must have a switch or hub. That earlier under bus topology, I explained you it no need to hub or switch. But if you are supposed to use a star topology on your local area network, in that case, it must need a hub or switch. All other devices should attach around the star. Should attach around the hub or switch. Once you attach all of these devices around the star, it looks like a star. That is why it says star topology. Right. Look at the description here. Star topology. The one of the most common common type of topology you can use within your local area network. All of the nodes you can attach with the hub or switch. That means no way to direct transmission. That means one node is not able to directly contact with the other device. It must if you want to connect one device to the other device, you must use the switch. All of this data you should send through the hub or switch. Right. Here the central computer is known as server, and the other computers known as client. In star topology, it need to assign one main computer that is called server. Also, this feature is not you find in the bus topology. No server there. That means any computer can consider as a server. That is under bus topology. But if you are using star topology, that means you need to assign one main computer that considered as a server. All the other computers considered as a client computers. Right. Then consider about the cables you can use to establish the star topology. They are also using coaxial or RJ45 network cable, that means twisted cable. Also, they need the network card, each and every computer in the topology, right? That's the very similar. These things also you can find under bus topology. This is also we need all of these other devices, other things to establish the network topology. That means you need coaxial cables or RJ45 cable. That means twisted pair cables. Also, you need a network card. Right. That's about the basic idea about star topology. Now you can write down this description on your books. Right. Write down it. Right here, I think you finished writing the things here. We are discussing about the star topology. Here, the main point you want to remember, there's a central hub. All the devices are not attached around this hub or switch. Right? One computer you need to assign as a main computer, that is known as server. Once you assign one computer as server, then all the other computers are known as client. Then to connect the computers, they are using coaxial cable or RJ45 network cable. Actually here, remember that depend on the network card, which it depend on the network card your computer having. According to that network card, that it says that particular port available. Some network card having BNC code, some network card having RJ45 card. And if you are having RJ45 port, mean you want to use twisted pair cable. If your network card available with the BNC port, mean you want to use coaxial cable. It depends on the network card available with your computer. Right, now look at the diagram here. It says how physically arrange a star topology with the nodes. Right. This is the way of arranging the devices of the star topology. Don't draw this one. Here in the device in the middle, known as the central hub. Around the central hub, you can see all other devices attached with the star topology. Right. Then look at another diagram here. That's much clearer one. Draw this one on your books. Right. The central device is known as hub or switch. Within bracket, you can say or switch. Then computers, printers, and servers you can attach around the hub or switch. Right. Draw this diagram. Right here, I think you finished drawing the diagram. According to this diagram, there's a central location. The device you can use as this central location is hub or switch. Within bracket, you can say or switch. Then around the hub or switch, you can attach other devices. Other devices mean it may be a computer, laptop, printer, server, like that. The one of the device you can assign as a server in this server is not mentioned in this diagram. Remember that point. One of the computer here you can assign as a server. Then the other computers become clients. Right. Here, think about the data transmission. How happened the data transmission? That means the logical topology. Each and every time when you need to transfer data from one location to another, it should happen through the hub, central location. No way to connect two devices directly. Always you must send in data through the hub. That's the way of transmission data from one location to another location. That's the important point to remember. Therefore, write down this one also. Data transmission should happen through the central hub or switch. They are not allowed direct transmission between two devices. That's the one important point under star topology you have to remember. That's the way how data travels from one location to another location. You must traverse this data through the central hub. No direct transmission is allowed. Right. Write down these lines also on your books. Right. Okay. I think you finish writing the things here. Also look at the diagram. This diagram also. Here the representation of the star topology through another way. Here you can find the central hub or switch. Each and every time the station should send data through the switch or hub. The way of transmitting data here you can see as an animated animation. Always you can see there are no direct connections. All of this data should go through the central hub or switch. Right. Then this particular star topology, that at this end right end you can see another connection to a world, that means internet. If you want to connect this star topology, this one, to the internet, then they are using another special device. Can you suggest someone what's the device here? We learned this one also last week when you are discussing about the devices need to the network system. If you want to yes, that's good, very good. Router, that's the equipment or device you need to connect with the internet. Then remember this point, don't need to draw this diagram again. Right. Okay, that's about star topology. Here we should want to know some advantages of star topology. Therefore, now we are going to discuss some advantages. Here, mainly we can identify 4 types of advantage here. The first, they are saying network control. Network control, whatever the changes you made to the network, it will automatically accommodated for the required other locations also, especially for the software changes, not for the hardware changes, especially for the software changes. Once you did for the one location, it will automatically accommodated for the other required locations. That is one of the advantage under star topology. Then limited failures, that's also you can identify under bus topology. The same advantage you can appear under star topology also. There are some limited breakdowns or failures happening under star topology. Also another thing here, one of the device, breakdown of one device will not affect to the work of entire network. That's another advantage. We can easily identify it. Breakdown of one location will not affect to the work of other computers or other devices of the network. Then familiar technology also we can identify under but topology. We can easily connect with each other. Installation is easily cost effective, low cost type of arrangement, this one. Therefore we are saying familiar technology. Then easily expandable, without any difficulties. You can add another device, additional device with your network system. There are some network arrangement. If you want to add new devices to the network, you want to stop the network system, then after that you can add devices to the network. But if you are using star topology, then no need to shut down the topology to the maintenance. So adding new devices to the system. That is called easily expandable. Right? That it says easily expandable new station added to open port on the hub. Right. But however, here the problem is the port is limited. It depends on the size, number of ports available on your switch. Right. If your switch available 25 port, then only you can add 25 computers or devices with your topology system. Right. Okay, you can write down these advantages here on your books. Right. Write down these advantages. Right, I think you finish writing these advantages here. This in short, we can say the first one, network control, that automatically accommodated once you change, once you doing some changes to the software of your network. Then limited failures, breakdowns are very rarely. One breakdown of one device will not affect to the entire network. Then familiar technology they are using to installation and the other things. Then easily expandable, without shutting down the network system, you can add devices to the system. These are some advantages regarding the star topology. Then we'll see some disadvantages. Here, point out some disadvantages of star topology. Here, the first one say higher cost implementation. To implement the system, that actually the initial cost may be somewhat higher. The cable cost may be low, but if you are establish some advanced type of star topology, or if you want to add more devices, 50 to 100 devices, then in that case you want to spend more money, especially for the switch or routers. Switch cost may be somewhat high when compared with the other devices. Therefore, the cost may be implementation cost may be high. Then another disadvantage here, that determines the performance. Central network determine the performance. That means that earlier I mentioned, according to this arrangement, all the things determined by the central location. That means central hub or switch. Something happened to this central location. What happened? Entire network may be stopped. The working, not working the entire network. That is one of the disadvantage. We have to wait until repair the central location. Right, then another disadvantages, central computer hub or switch fail. Entire, that's the third one actually I explained. Once you fail the central location, you want to stop all the other network. Then second one explained, the central network device determines the performance and number of nodes the network can handle. That's the one I explained earlier. If you are using switch or hub, that will limit to the number of devices you can attach with your network. That it determines the number of devices you can use on your topology. That means suppose you are purchasing a switch that having 45 ports, that means you can only fix 45 computers to the network. Then according to the requirement, it may be with the time you want to fix more computers, right, according to your requirement. If you are, or if you want to add another 15 computers, then what happens? You want to buy another switch. Right? Therefore, the number of computers or performance of your network system determined by the central location. Right? That's the thing explained under second disadvantage. Then third one says what happened? The breakdown of the central location or switch. Once you having some errors with your switch, that means it will affect to entire network. Right. That's about some disadvantage of the star topology. Now you can write down these disadvantages on your books. Right. Write down this one. Right, okay, then I think you finish writing these disadvantages here. Here is disadvantages regarding the star topology. That's the second topology type we discussed here. The first one, bus topology. The second one, star topology. Then we can move to the next one, next type of topology called ring topology. You can write down on your books as a subtopic, ring topology. Right. Here, this one also name suggests that the type of physical layout, physical arrangement, ring. It's like a ring. Once you arranging the devices under ring topology, the outer appearance of this ring topology is like a circle or ring. There is a no starting end or no ending point, because it's all devices you arrange in a circle. Therefore, no, like a bus, no starting point or ending point. In a bus, you know, bus topology, there is a starting location that is called terminator, ending location that is called grounded terminator. In that way, you can't find any starting or ending location under ring topology. Right. Here, giving the description of ring topology. Always, if you want to send in the data under ring topology, that particular location have to send this data to the next location. The next location send in data to the other one. In that way, or you can pass data to the destination location. Right? It's no way to directly connect with the required location. Always that particular location link with the other two neighboring locations. Right. That's the way of sending the data from ring locations. Right. Write down the things here, all the things I explained. Write down now about ring topology. Right here, I think you finish writing about ring topology. The name suggests the way of physical arrangement. All the devices you can attach with a circle, in a circle. No starting or ending locations. And it's around a circle. Always that one particular device is connected with two other neighbors to the next location. That the particular device which supposed to send in the data first should contact with the next location. Then the next location send into the other next location. Then like that the data should arrive to the destination path. Right. In that way we can arrange the ring topology. Here look at the diagram about ring topology. All the devices arranged in a circle. Here, remember this point, it will not mention in here in the descriptions. If you want to send in the data to a particular location, suppose you want to send in this location, here the very first this location to the this location here, data send in only for the one direction. It's a clockwise direction. Only you can send in data in clockwise direction. No need, no way to send in the other direction. Only the one direction. That's the one point you want to remember. If you are sending the data, the first thing is what that particular location doing is send in the token, release a token to the network. That saying, that token saying the particular location where to send. That means address of the location to send in the data. The token says the address of the location to send in the data. That first release the token, then token create the path. Right? That particular token going to the next location. Then next location check the address, not this address for the second location there. For it sent to the third one. Then third location check the address again. Then it not for this third location. Therefore, the third location send location to the next one. Then this location, fourth one, check the address. That particular address is similar to this fourth location. Therefore, it established a path between this first location and the fourth one. The first establish the path, then try to send, then start sending the data. Then start sending the data. That's the way sending data in the ring topology. That means the pattern of sending the data. That means logical part of the topology. I think you can understand it. It is not mentioned in the description here. Therefore, you want to remember it. That again, I explain it. If you want to send data from one location to another location, suppose, for example, you want to send data from this first location to the fourth location. First location to the fourth location. First one is the very top one, then second, third, fourth. In that way, you want to identify the location. Data sending happen only for the one direction. That is the clockwise direction. Right. The first location, if they want to send in the data, then what's happening? They are starting sending the release a token. Release a token to the network. That token says the destination address. Then that particular token, the first go to the second computer, then second computer check with the address, not for the second one. Then the second computer sending it to the third one. Then third computer check with the token, not the address here. Therefore, the third computer sent to the fourth one. The fourth computer check with the token. If then fourth computer identified that the token address is similar to the on computer. Therefore, fourth computer and the first one make a path. Then first computer can start sending the data to the fourth location. The first establish the path, then start sending the data. How establish the path is using a token. Therefore, sometimes you hear this particular topology also known as token ring topology. Token ring topology. I think you get that point clear. Draw this diagram. First, draw this diagram here. When you are drawing this diagram, refer this one, right? The modified, no need to delete it. If you are starting the diagram, complete that one and name your diagram in that way. Station, station, station. Then direction of flow. In the direction of flow, here you can see another label called token. That's the token I discussed earlier, right? Draw this diagram. Right, I think you finished drawing this diagram here. This one is more clear one. Look at the way of rounding data of this type of ring topology. Look at the diagram here. Right. Get from this point, this yellow color one, this is the station where you need to send in the data. It first release a token to the fourth one. This fourth one is need to send in location to the first one. Therefore, in pink color, you can see giving the token. Right. After establish the path, they are begun to send in the data. Right. Look at again the first yellow color one, release token 2, 3, 4. Then station 4 need to connect with 1. Then station 4 release in pink color token to first. Right, now two path is established. Now start sending data. The same thing happening again. Look at the again. In yellow color token, go to the 4. Then station 4 need to connect with 1. Then pink color token, go to the station 1. Now two path is established here. Now starting send data. The same time here, it is okay to send in two connecting two devices in the same time. It is possible, but more than two is if you are trying to connect more than two devices, in that case collide is happen. Two devices okay, but more than two, maybe collide happen. Right, I think you can get a clear picture from here. Right, now we'll see some advantages of ring topology. Advantages of ring topology. Look at the advantage here. All data flows one direction. Only they are allowing to one direction. It reduces the chance of packet collision. Packet collision, though data collision. The collision means that earlier I mentioned collision happen if they are trying to release sending data same time. Two devices sending data same time. But in the ring topology that earlier I mentioned it, under ring topology, it is possible to send two devices sending data same time. That means collision reduce, not completely avoid, but reduce it. Right? It is okay to two stations sending the data same time, but 3 stations or 4 stations trying to send in data same time mean again collision happen. But when compared with the other two, star and bus topology, the ring topology's collision is low, reducing. That's the advantage. In this case, the secondly says no server is need. That means no need to specify special computer as a server. That means any computer in the network can consider as a server. Right. Then speed is somewhat higher than the bus and star topology. That's another advantage. Then next one, they are saying additional workstation can be added without impacting performance of the network. Right? That's also another advantage, like star topology. Here you can add additional workstation without giving without disturbing the performance of the network, without disturbing the performance of the network. Right, okay, write down these 4. Right, I think you finish writing the things here. Here discussing the advantages of ring topology. The first one says there's because of sending data to one direction, collision you can minimize. At the same time, two devices can send in data. That's one advantage here. Then no need a separate computer, main computer assigned as a server. Then between two workstation, transfer data between two workstation is high speed. But you are sending the data, the particular that if you want to send in another location, not the next one, if you want to send in data to another remote location, that all the data should want to go through the every computers up to that particular location. Right? It may be reduce the speed. Only the next location, sending the data to the next location is high speed, but if you are sending the data to the remote location, all of this data go through this each and every devices up to that location. Therefore, reduce the speed, sending speed is somewhat low. It may be a disadvantage. Then last one says additional workstation can be added without impacting the performance. It not said you can add other devices without shutting down the network. Here says without impacting the performance of the network. Suppose, for example, if you have a ring topology with 5 computers, then it will be able to send in data 5 megabytes per second. Suppose 5 megabytes per second. Suppose you need to add another computer, 6 computer to the network. Once you added the 6 computer, it will not affect to the speed of the network. That earlier it assigned as this 5 megabytes per second. After you added the new one, the speed is not changed. The same, still 5 megabytes per second. Normally what happening the other network type is once you added the new devices, the speed is become reduced. But in the ring topology, once you added the new devices, the performance will not change. That's the point you want to get under the last one, advantage. Right, I think to finish writing these advantages, then we'll discuss some disadvantages also. Here the first one says all data must pass through each workstation. All the data you should pass through each workstation until finding the required one. In between the sending and the destination, there are some location. All of this location receive the data that affect to the speed of the star topology. Then second one say what happen when one workstation shut down or breakdown of the one workstation. It will affect to the entire performance network work of the entire network. If you break down one computer in the network, if you want to repair it, you want to shut down all the devices in the network. It will affect to work of entire network. Then third one says if you want to establish ring topology type, it will need more expensive devices. The Ethernet card is more expensive when compared with the normal network card. The hubs and switch costs are also expensive. Therefore, to establish ring topology is comparatively higher than the cost is higher than the other networks. Right, now we can write down these disadvantages also. Right, complete the note. Right. Okay. I think you finished writing these disadvantages of ring topology. Right here, the end of discussing the ring topology part. Up to now, we completed to discuss three types of topologies. Bus topology, the first that earlier morning we discussed. Then star topology. After that, we discussed about the ring topology. Right here, we still have to remain in discuss tree and the mesh topology. Then I will give a break now. Then after that, I will continue from that point. I am going to discuss mesh and the tree topology. After that, I want to do some activities with you. And also I am supposed to discuss some past paper question. After the break, I will try to do those parts. Right, okay, then is it clear up to now, today's lesson? What about the today's lesson? Is it clear? Is there any doubts, or you can ask any if you have any question regarding the lesson? Is it clear up to now? At least tell me.
Yes, sir. Clear.
Right. What about the others that earlier I mentioned last week also? Feedback is important. Your feedback is important to continue the lesson. Therefore, at least tell me yes or no, or give some messages through the chat box, right? Okay, I think you are clear now. Therefore, I'm going to stop for now. Then after the break, I will start at 11:10 a.m. Right? Okay, we'll meet after the break. Right, okay, then we are going to start from now. I think all of you are joined after the break here. Right, here we are going to continue from the point where we stopped before break in. I think we discussed the topologies, bus, star, and ring topologies. Here we have to next topology type we are going to discuss tree topology. Tree. That's tree topology we are organized as a hierarchy. Right? That's a somewhat differ. The arrangement, physical arrangement is differ from the other three types. It's like a hierarchy. The hierarchy mean, I think all of you know, there is a top element, then there are some other elements you can link with the top, then other elements you can link with the second layer. The layers you can find top, second, third, like that. In that way we can arrange the devices and nodes in the tree topology. Then look at the diagram here. The first look at the diagram here. The top element you can find at the top of this hierarchy here. To the top element, there are two other elements that link with two other elements. That is called the second layer. Then another four elements add to the second layer. That's the third layer. In that way, you can add a number of layers to this hierarchy. The top element of this layer called as root element or root device. The other elements we known as the descendant element. Right. That's the way how arrange tree topology. In this description says that what I am discussed now. All the computers and other devices are connected in hierarchical fashion. Hierarchical fashion is like that. This is the figure that you can see, hierarchical fashion. Then topmost node, that means the first element of this hierarchy is called root node. The other elements called as the descendants elements. Right. There's only one path exists between two elements. That's also a point out here. If you consider the root element and the first element of the second layer, in that case you can have only one path, one link. Similarly, if you consider the first element of the root element and the second element of the second layer, in that case again you can see one path. Right. Then if you are going through below this diagram, any of the two links, two devices you consider here, only one link you have. Any two devices you consider here, only one link you can see there. Right? Therefore, it is form another view called parent-child hierarchy. Right? It's form a parent-child hierarchy. That means always the top layer is the parent, the below layers are considered as a child, parent-child. Right? That's another name we can give for this topology, parent-child hierarchy topology. Right? Okay. Now you can first description. Write down the description here, then draw the diagram. Right here on write down the description only. Don't draw this diagram. I will give another diagram to draw. Don't draw this one. Only write down the description here. Right, I think you finish writing this description here. Don't draw the diagram. This discussion about tree topology, your nodes or your computers can arrange in hierarchical fashion. The hierarchical mean the figure like that. There's a device at the topmost that is called root device or root element. Under this root element, you can attach the other layers. In this case, in the second layer, you have only 2 devices. Under the second layer, you can add another layer. That's the third layer. Here, you can see 4 elements there. Actually, this by referring this diagram very carefully, we can identify this combination of both bus and star topologies. Tree topology is a combination of both the star and bus topologies, right? That again, I show you another diagram. In that diagram, you can identify the bus topology path and the star topology path. Right. Before that, you want to draw a diagram for the tree topology. Draw this diagram on your books. Much clear diagram. This one here, the first element called as the node 1. This node 1 links to 2 other elements that is under node 1. That's the second layer. Node 2 and node 3. Draw this diagram. Then node 4 and 5 under node 2. node 6 and 7 under node 3. Draw this one. Right, then look at the diagram, this next diagram. No need to draw this one. Here I already mentioned the combination of both the star and bus topology. That's also another way of identifying the tree topology. Here very clearly we can see this backbone cable. This backbone cable is a feature of bus topology. Throughout this backbone cable, then you can see branches. Left side you can see one branch here. This branch is an example for star topology. In this branch in the middle you can see a switch or hub. Around this hub there are 3 nodes here. That's a feature of star topology. In that way, similarly you can see the right side. Another branch here. There are 2 sections in this branch. The lower one is 2 computers and 1 hub. The upper branch is 2 computers and again another printer and a switch. That's according to the star technology. These branches are created according to the star topology. Therefore, the tree that hold together, this whole diagram we can consider identified as a tree topology. Right. No need to draw this diagram here. Now we'll move to some advantages of tree topology when we compare with the other topologies. The first one says support for broadband transmission. Broadband transmission means at a time you can send in more data. The volume of data sent per time is very large. This broadband they are supporting this type of technology topology support for broadband transmission, and also it refers to signal transmission to long distance. Right? If you are supposed to establish the network through long distance, in that case, the much better arrangement is tree topology. It supports to establish long distance networking without being at nation. At nation, I think you can remember that very first classes I introduced one of the feature, signal feature. At nation means you need repeaters. Right? The signal strength is where strength become lower when the distance. Right? Then if you want to get more strength, if you want to get more strength signals, then you need to put repeaters. Right? But if you are using this tree topology, it supports for long distance cabling also. That's the advantage, first advantage of the tree topology. Then easily expandable. Adding new devices mean not a difficult task. At the last layer, it is very easily you can add additional devices. Then another advantage that not find under the other 3 types of topologies: error detection and error correction. It support easily detect the errors, and also it support to repairing these errors easily. That's another advantage. Then again, like other three topologies, there's also limited failures, right? Breakdown is very rarely. One station, breakdown of one station does not affect to the other devices of the topology, right? Those are the some advantages you can find under tree topology, right? Now you can write down these advantages on your books, right? Right. Okay. I think you finished writing this advantages of tree topology here. They are saying the first one is support for broadband transmission. The broadband transmission refers to sending data, the volume of data, right? Sending the volume of data at the time, it's very high, and also refer to the over long distance cabling also. Right, then second one, easily expandable without affecting the other performance of the network. You can remove in and add in the devices. You can do it. Then error detection and error correction are easy. The limited failures. Right, those are some advantages you can find under tree topology. Right, then we'll see some disadvantages here. Difficult to troubleshooting. If any fault occurs in the node, if you find some errors in some nodes in between the hierarchy, then finding this error is difficult to troubleshoot. Then cost very high to establish this type of hierarchical network. Need more money. You have to spend more money to establish this type of network. Please mute your microphones. Please mute your microphones that it disturbs the audio. Please mute your mouth. Please mute your microphones. 079. Please mute your microphone. 079, please. Right, okay, we are discussing about tree topology, disadvantages. Then you want to spend more money to establish this type of network system. The devices costs are very high. Then failures. Tree topology mainly relies on main bus cable, and failure in main bus cable will damage the overall network. I think you remember that earlier I mentioned tree topology is a combination of bus and star topology. The bus topology means it has a main cable. Main cable means backbone, main backbone there. Once some damage happen to this backbone mean it will affect to overall performance and work of the network. That therefore the failure mean that sometimes on the tree topology these types of damages will happen. Then reconfiguration is difficult. That thing also earlier I mentioned. There are many configuration things you want to do when you are adding computers or devices to the network. In software aspect, there are many configurations you want to set. Then IP addresses you want to set, dynamic addresses like that. There are many software things you want to configure. Once failure or breakdown mean you want to reconfigure it again. This reconfiguration is very difficult. Right, these are the some disadvantages you can find on your tree topology part. Right, you can write down these disadvantages also. Right, write down it. Right. Okay. I think you finish writing this disadvantages of tree topology here. Here, point out 4 disadvantages. The first one says difficult to troubleshooting. If breakdown happen in the node, then it is difficult to find out. Especially, it is difficult to find the place where that particular error occurred. Once the error find that place occurred, the error is find, then easily you can repair it. That's the advantage. Disadvantage is here to find in the location. Right. Then the second one, high cost, especially its support to broadband transmission. It means you have to spend more money to get in support to this broadband transmissions. Then failures of main cable, that means main bus cable or backbone, it will affect to overall performance of the network. Then the last one, the reconfiguration is difficult. You need that earlier I mentioned, there are many types of configuration when attaching devices to the network. Once breakdown it means again you want to configure it. That is called reconfiguration. Reconfiguration is very difficult when you are attaching or when you are repairing the devices once breakdown. Right, that's about disadvantages of tree topology. Then we want to move to the our last type of topology called mesh topology. Right, here that before moving to this mesh topology, please look at the diagram here. Tree topology diagram, this one. That I think you remember earlier I mentioned, when you consider the devices here, only one link you can find. If you consider the first device and the first device of the second layer, only one link there. In the tree topology, each and every devices we consider, in that case you can find only one link or one relationship between two devices. You can't find other types of links here. That for example, suppose you can't find any right here, the drawing is not possible in my case. Right, here look at the screen here. Right, here the diagram. Suppose the links between in this cell. Right? Consider the top element and the first element of the second layer. If you consider the first element, first device of the second layer, Right? In this case, you have two relationships, one for the top and the other for second device of the second layer. In the tree topology, this is not allowed. You can't put links like that. But if you consider the mesh topology, mesh meaning you can create the links, make links like that. If you consider a device, you can create links for any other devices. Right? There are some mesh topologies, all types of links available with that topology. That is called full mesh topology. There are some other topologies, mesh topologies, partly you can see the links. Those are called partially mesh topologies. Right, then we'll move to the diagram of these mesh topologies. Right. Here the mesh topology, here explaining what is mesh topology. It says it represents all the relationship between devices, not like tree topology. Tree topology shows only one relationship between two devices. There are two types of mesh topologies that earlier I explained, mentioned it: full mesh topology and partially connected mesh topology. Full mesh means you can find any all number of links between devices. But partially connected mesh topology, at least two computers in the network make relationship with others. Right? In that way, you have to identify the difference between this mesh, full mesh and the partially connected mesh. Right. Before drawing the diagram, first write down this note here. Write down this one. Right. Okay. Here, I think you finished writing this one, mesh topology. Here, the important point to remember, mesh topology. Under mesh topology, one computer should provide links to all other computers. One computer in the, still you have need time to complete it. Okay, I will give 1 minute to complete that. Right. Okay. I think now you finish writing this description about mesh topology. In a mesh topology, if you consider one computer, this one computer provide links to all the other computers in the network. At least there are two types of mesh topologies: full mesh and partially connected mesh. In the full mesh topology, if you consider one computer, it should provide all the links for other computers. But if you consider the partially connected mesh, in that case, one computer in the mesh should provide at least two links to the other computers, at least two relationship with other computers. But if you consider the full mesh, you need to establish all the links with one computer to other computers in the topology. Right? Get that difference between the full mesh and the partially mesh. Right. That's about mesh topology. Look at the diagrams here. Right. This one example for. Can someone tell me this is full mesh or partially mesh? To determine that, identify the links. If you consider the node 1 here, node 1, then it should provide links for all other nodes in the topology. Right? If you consider node 1 to node 3, then you can see a link. If you consider node 1 with node 4, then here again another link. Node 1 to node 2, another link. That means if you consider a link, it provides all the links for other devices in the topology. The same way, if you consider another device, it should also be provide links for other computers. If you consider another device, it should provide links to all other devices in the topology. Right? Therefore, in this diagram is an example for full mesh topology. Full mesh topology. Right? You can draw it here. And below mentioned, this is full mesh topology. Then can someone tell me how many links in this mesh topology? How many paths, different paths available with this topology? Count and tell me. Can someone tell me?
12.
Sorry? 8? Any other answers?
12.
12? You can count it. Consider the node 1, node 1 to others. There are 3 paths. Node 1 to node 3, node 1 to node 4, node 1 to node 2. And here there are 3 paths available. Then if you consider the node 3, then 1 to node 2 here and 1 to node 4. Then if you consider the node 4, the 1 to node 2 here. All other parts already mentioned. Right? Therefore, you can count it 1, 2, 3, 4 in between, in cross way available another 2 links. Therefore, together how much? 6. Right? That one student say the answer through the chat box 6. That is correct. Right? In that way, there is a formula to find the number of links in the mesh network. In this formula, before giving the formula, look at this diagram also. This is another example for full mesh topology. Right? No need to draw this diagram. However, tell me how many links there. How many links? Here you have 6 devices. It is very difficult to count it, no? In the topology, number of devices, if increase the number of devices, then it will very difficult to calculate the links. Therefore, there is a formula. There is a formula to calculate the number of links here. Right. Before giving the formula, again see this one, this diagram. What can you say about this one? Is it full mesh or partially mesh?
Partially mesh.
Partially mesh, because there are some links are missing. In the definition says partially mesh, at least you need 2 links from one computer to other. At least you need 2 links. There are some computers made here 2 links. Therefore, this mesh we can consider as a partially mesh. Right? But there are some links are missing. Therefore, not full mesh. Right. Okay. In that way, you have to identify the given network is mesh or a full mesh or partially mesh. Remember that point. This one, no need to draw the diagram. Here, right. Formula you have to remember to calculate the number of points, number of links here. Right. Then write down in your notes the formula used to calculate number of links in a full mesh topology. The formula to calculate, don't draw the others, right? I get for me. The formula to calculate number of links in the full mesh topology as follows. Suppose number of devices is n, then number of links I called as num, number of links equal n, open the brackets, n minus 1, n minus 1 divided by 2, divided by 2. Right. Number of links here, number of links equal n into n minus 1 divided by 2. Here n equal what? N mean number of devices. In the below this formula, write down n equal number of devices. Number of devices. For example, suppose you have 4 devices with mesh topology, then how many links available? How you can find it? Substitute 4 into the n equal 4, then 4 minus 1, 3, divided by 2. Then 12 divided by 2 means 6. Number of links 6. That earlier I can remember you calculated it by looking at the diagram with 4 devices. And your answer was 6. Now directly using this formula, you can get the answer, number of links. Right? That if your devices suppose 6, then how many links available? If it is 6,
15.
yeah, then substitute 6 instead of 10. That means 6 into 6 minus 1 means 5 divided by 2, 15. Remember that formula. Sometimes in your question paper, I think last time I show the question like that. They are giving the number of devices, asking the number of links. Right. Okay, I think you get the idea about how to find in the number of links there. Right, we'll now move to the advantages of mesh topology. Here they are giving some advantages. Here says manage high amount of traffic because multiple devices can transmit data simultaneously. Here multiple devices, it allows to transfer data at the same time, more devices at the same time. That earlier cases only 2 or 3 times that say they are allowing to data at the same time. But if you are using mesh topology, in that case they are allowing sending data more devices at the same time. That's the advantage. Then second one, failure of one device, then they are saying does not cause to break down the entire network or transmission of data. Break down one path or one path mean, break down one path mean it will not affect to data transmission because there are many other paths available between 2 devices. Right. Then adding additional device does not disrupt data transmission. That's also another advantage. Adding another device mean it will not affect to transmission of data, because there are many paths available to transmit one location to another location. Right. Write down these 3 advantage here. Right. Okay. I think you finish writing these advantages here. Then we'll move to see some disadvantages of mesh topology. Disadvantages here says cost, regarding the cost. Implementation of mesh mean you want to spend more money. Cost is higher. Then building and maintaining the topology is difficult and time consuming. Here you want to use more cable and more devices. Handling more cable and devices mean time consuming, and it also difficult. Then a chance of redundant connection is high, which adds to the high cost potential for reduced efficiency. Redundant connection mean the same connection, right? This type of mesh topology provide same connection to one devices to other, right? Therefore making same connection mean you want to spend more cable and more money for that. Therefore it will be sometimes reduce the efficiency of the topology. Right. Write down the disadvantages of this topology also. Right. I think you finished writing the things here now. This is the things today I want to discuss about these topologies and types of topologies. Then I want to do some activity. We have another 20 minutes. Therefore, I am going to do one activity with you now. I am giving the code here. Then I am publish it through the chat box. Then you, before getting the code, you want to go to this link. I am giving a link through the chat box. Please go to this link first. Right. Then I posted a link to there. Click on the link here. Right. Then I am giving a code. You want to type this code. Once you get in this particular website, there is a place, red color box there, student, saying student. Then there is a box to enter the code also there. Enter the code, and there is small arrow. Click on the arrow in front of the coding. Then you can start the activity from that point. Right. Then now I am still not giving the code. Right. Now you can see the code through your screens. Still open the screen here. Once you open it, the screen, then you will display the code. Right, now I think all of you can see the code here in capital letters, the code available. Please type this code in the student section that earlier I gave you the link. Go to that link. In this page, you have a red color box called student. Under that, there is a small box to enter the code. Enter this code to that box, and in front of there is an arrow. Click on the arrow there. Okay, are you clear there? You are doing?
Yes, sir.
Right, okay. Then they are asking your name. After that, asking your name. Please give your actual name. Please give your actual name. Then under that, ask another short name that is optional. No need to give anything for that. Just give your name, and after that, there is a button called join. Click on the join button. Or someone asking, is that assignment? No, this is not assignment, but I am expecting to do this type of thing. Right? I am checking now how your participation here. If it is okay, then I will expect to give it an assignment like that. Right? Therefore, this is not the assignment, right? Therefore, please participate for this one. This type of assignment you will be assigned future as assignment. Right? Still no one joining it. Right, okay. There are some students, 30 students here. Atapattu, Bhagya, Chaturika, Dilini, Dishna. Then what happened to others? 95 students already joined with the Zoom session. But 30 of you join with this activity. Please try to join the others also. Right, then 35 students. Right, if you having with the problem with code, I can show again it. Here I am going to give in this code to the chat box. Right. here, this is the code, right? 9CNEL, all are in capital letters. Right. Still 36 of you connected with this one, 37. Please try to connect with this activity. If you are having with problem joining, please first go to the link I provided earlier. That I am going to give this link again. In the chat box, check the chat box. Right. This is the link you want to click. Click on the link here. Once you click the link there, then you will move to another screen. In this screen, there's a location red color box labeled as student. In the student box, there is a place to enter the code. Now you can enter that code which I gave now through the chat box. Also, you can find that 9CNEL, that code. Type the code and this red color box, and there's a small arrow, blue color arrow in front. Click on the arrow there. Then you will you can appear your name here. I think all of you can see this name list. Only 40 of you are connected. Right. However, because of the time problem, I am going to start it with this 40. Right. I am starting the activity is regarding the network topology. Right. Here the first activity is something right, and you want to send it. I am going to start it now. They are asking briefly explain what is network topology and name 5 types of network topologies. Only 4 minutes are allowed to complete that activity. Right. I am going to start it. Right. Now you can write down the answers. Once you write down the answers, then you can submit it. Remember the time. Now start counting the time. Only 4 minutes available for. Right now, the time is over for this question. We can check some of the answers you gave. We'll see. Some answers. Prasadi Upeksha. Prasadi giving this answer like that. Network topology refers to the physical or logical arrangement of a network LAN. It defines the way of different devices are placed. Yes, very correct. Very good. They are giving the examples also. Bus topologists are like that. Right. Very good answer giving Prasadika. Then we'll check another answer. Punsala Kumartunga. No description, only the examples. Bus, tree, ring, mesh. Like that. Then Sujit Chaturanga says network topology is the way different devices are placed and interconnected with each other. That's also acceptable answer. Good. Then Chaturika says the physical and logical network topologies of network do not necessarily have to be identical. Here actually we are asking, the question is asking what is topology. Then you giving some features. Topology means that direct answer it need physical arrangement of the computers in a LAN, local area network. Right. Then Nishadi Madhushika says network topology refers to the physical or logical arrangement of the network. Right. Better to give in at least within brackets say local area network. That otherwise good answer. Giving the examples also. Right. Then we'll see the next activity. Because of time, I have moved to the next activity. This one may be the last activity we want to do today. Right, here you have 8 questions. I am going to start it now. 5 minutes available to complete that question set. Right, I am going to start it here. At only 5 seconds available. 5 seconds. 4, 3, 2, 1, 0. Now time is up. I think all of you are doing that very well. Maximum marks here giving 7 out of 8. 7. Who is getting 7? Yes, Prasadi, Upeksha and Sevandi getting the maximum marks, 7 out of 8, that we can check the answers of Prasadi. She, I think, wrong with the first question. Mesh topology have devices which are connected via topology which requires the central controller star. That first question is wrong. It should be point-to-point link. Point-to-point link. Point-to-point mean one computer with other. Right. All the other answers are okay. Yes. In the Sevandi, he wrong with the third question. Which topology have 2 or more branches? 2 or more branches. The branches are available with which topology? Branches are available with tree, not bus. You are giving the bus, but it should be tree. Here, then we'll check another answer. Then HMDD Herat getting 6 out of 8. He wrong with question number 1 and 6. Question number 1, multi-point. It should not be multi-point. It should be point-to-point link. Right, the first question. Then he, I think, question number 6. Yeah, wrong with question number 6. In network, participating computers are referred to as nodes, not only nodes, both, nodes are not, it is incorrect, right? Nodes incorrect. Participating computers are referred as both server and client. Participating computers, right? You want to point out that word for computers, right? Participating computers, both server and client. If it is asking participating devices, then nodes is correct, right? Then our time is past now, therefore I am not having time to discuss all the questions and answers of you. Therefore only the selected students I get into discuss, right? Here I am going to stop the lesson. Also, there are some more activities here. We have no time to complete these activities. Then try to do it next week. Okay, then I'm going to stop the lecture now. Okay, thank you very much for the participation.
Thank you, sir.
Yes, sir.